Assalamu alaikum everyone. Today we are going to discuss inheritance. But we should take a review of our last lecture. And our last lecture we discussed the static data members. Actually, static data members are shared spaces. Instead of storing the similar data at a object level, we stored that at a class level. So let's take one example. For example, you have one website, and for that website you want to show the counter for every users which are joining or visiting your website. So for that, for example, you want to show here as a counter, and if the single user is online, the counter will be 1. If the two users are online, both of them will see the online user count as 2, and if there are millions of users there, then they will see the same count as a million user at the same time. So if we create objects for that, for example, this is the objects which is created for the user 1, and we have placed the online users at the object level, so data is being stored at that object level. Similarly, the user 2 have the same data for online user, the user 3 have the same data, the user 4 also have the same data. Now you can see that the data is same, the count is same, because as the users increases, as the visitors increases, the number of count also increases, but everyone see the same data. So what will happen actually? Every object has a separate storage for that, separate memory for that, so you are burdenizing the memory. This will decrease the performance of the system because you are using the same data in every object. We can store that at a single place, and after that we can access that data in the object. But there is a next issue also. When we were studying the object-oriented programming, particularly in the classes that we discuss, that classes is a blueprint, these are the designs, these are the just instruction to define the objects, and classes are not going to store any data. The data is always stored at object level. So definitely this is a problem. According to the object-oriented definition, we have to store the data at object level. We can't store data at a class level. But when we store data at object level, we can see that there is an issue that repeated data is stored for every object. We don't need that for everyone. So what we can do for that? We can go towards another technique. For example, I create one shared space, shared memory, and in that shared memory the count is saved. Now the objects individually are not going to have the count in their objects. They will get this data from these shared spaces. So when the data is received from that shared spaces, they will not have this data. This will definitely optimize the memory and computational performance, because in the case of millions and billions of users, millions and billions extra space will be required to entertain that data. So that user shared space is declared at the class level. So you can say that the static data is a part of the class, it is not a part of the object is not going to have that data. So this was our last lecture in which we discussed the static data members, and today we are going to discuss the inheritance. Inheritance is a very important topic because there are 4 pillars which we discussed while discussing the object-oriented programming. These pillars are for example, the encapsulation. We have already discussed a little bit about encapsulation, that we can hide our data. The second one is inheritance, and today we are going to discuss the inheritance, and after that there is a polymorphism, there is abstraction, but we will discuss all that later on. So we know about encapsulation currently, that we can use access modifier, private, public, and protected to encapsulate our data. And today we will discuss the inheritance, that what actually inheritance means, what basic problem the inheritance is going to solve, and why should we employ it in our programming to enhance the working of any program. So here you can see, from the day first I'm discussing the same program for the university level, and we are extending it level by level according to the usage, according to the requirement. So in the university, if we are going to write any application, develop any applications for the university, then previously we decided that we will need a teacher for that, we will need a student for that, we will also need an admin for that. There are also some other classes, but currently I'm taking only these three classes. These three classes are a part of that university system. Why? Because the teacher has some responsibility in the university, the student also have some responsibility in the university system, and the admin, the clerks and other administration, they also have some responsibility in the university system. So once we decide on that these are our objects, these are our classes, we go towards its design. Now here you can see that I think this would not be visible to you, but I will discuss it over here. That the teacher will need some data members. For example, you can see that teacher will need a name, it will need an address, it will need a phone number, it will need an employee ID also, and it will also need its domain or specialty, which is hidden over here, but it also need a specialty. In the same way, the student will also need some data. For example, student will need this name, student will also need the address, it will also need the phone number, a roll number. Any roll number will be assigned to the student, so student will also need roll number too. In the same way, the admin staff will also need some data, phone number, and it will also need the address. If you can observe here, you will notice some issue over here. There is something important over here, and this is the thing which lead us to go towards inheritance. Now you can see over here the data members in red are common. All these data members belong to teachers too, they also belong to the student, they also belong to the admin. But this is a violation of object-oriented programming, because in the object-oriented programming, when we started that class, in the first class we discussed that object-oriented programming is responsible for modularity, for reusability. When we were discussing the reusability, we discussed two things: that our code will not be repeated, we will don't use any repeated code, will don't use any repeated data members, we will try to reuse it instead. Okay, so we are not going to repeat the code, but here you can see that our code, our data members are repeating. The data members which we are assigning to teachers, all these data members are most of these data members are also a part of the student, they are also a part of the admin. This is a clear violations of object-oriented programming. So what we can do for that, because we are not going to violate any rules, so for that, what can I do? We can look at that with a different angle. I'm here designing another class, and the class name is a person. And at the person level, you can see that I'm defining some data members, for example, name, address, and phone number. And all these are those data members which were common to everyone. You can see over here that all these were the data members which were common to everyone. So after that, from that person class, I will inherit the teacher, I will inherit the student, I will also inherit the admin. So inherit means, as we usually find the inheritance in our daily life, that the child get the parent property in inheritance. Exactly here, the teacher will get the data members of person in inheritance, as the child is going to get the inheritance in our daily life. For example, you can see that our parents has provided something as in inheritance, so we are having that. Either they are a physical property or either they are any biological property. Along with that, we also create some other properties also, which make us a unique class, which make us a unique object. Exactly in the same way, because we are using the inheritance, the teacher will inherit all the data members. So you can say now the name is also a part of teacher, address is also a part of the teacher, phone number is also a part of the teacher, and along with that, these two others data members, which are employee and specialty, this is also a part of the teacher. So here in the student, you can see that the student will inherit all the data members from its person, from parent class, for example name. It will also get the address, it will also get the phone number, but along with that, it also has some individual data members which is making that student unique. In the same way, for the admin, it will also get the name, it will also get the address, it will also get the phone number, but along with that, we have some other data members for that, which is making that unique. So in that way, you can see that we get this problem solved, where the data members were repeatedly used for teachers, students, and admin, and the object-oriented don't allow to use anything repeatedly. So this is the way, and this is the reason we use inheritance to avoid the data repetition, the code repetition, and define the classes are important, are the common data members in a one class, and after that deriving that. So there are a number of inheritance. We will just discuss one of them. For example, a single inheritance, when from class A the class B is derived, as you can see over here, that from name we are deriving a teacher. There are a number of other inheritance too, but we will discuss all that later on. So let's first go towards the coding. We code it and check its behavior, that how actually inheritance work. We will code the exact class which we have just discussed here. We will create a person class, and from the person class I will inherit the other classes. So let's start. Include the header first. Using okay, and after that I will also need a main here, which is very important. So this is our program and its name is inheritance. This is the basic inheritance program. We need one person class, so class keyword, and after that a person. Person is a class name, and that person class we will define all the data members as we have defined over here. We will define the name, address, and phone number. So I'm keeping them public, and our data member is, one is name, the second one is address, for example, and the third one is phone number, for example. These are the three data members which we have defined over here. And the next thing is, I will also write one show function over here. If we want to show that, then we will use that show function. So this was our first class. The next thing is, we are going to inherit teacher from the person class. So in the teacher, we will need to add employee and its specialty. Okay, so let's go toward that. Here I will need another class. The class name over here is class. We will exactly write the same structure. We will follow the exactly syntax which is used for the class, and that class which is being derived from the person, that will also be considered a unique single class, as a single individual, as we have in our relationship that further has its individuality. And similarly the children have their own individual, they are they are also a unique person. So here I'm writing class teacher, and there is something little bit different. We will write a new syntax to inherit it from the person. In the person you can see that we are directly writing the body of the class for the person class. But here, because we need to derive it from the person, we are not going to add all the data members uniquely here in the teacher. We are just going to inherit it from the person. So I will use the colon, and after that I will use the data member from where I'm going to inherit it. And I am publicly inheriting it. Publicly means that all these data members will remain public if they are public. If there are any private member, they will be private and protected. So public is not going to change anything ever. Every access specifier will work accordingly. But if we change it to private, all the public and protected will be changed to private. And similarly, if you use here protected, all that will be converted to the protected. So I'm currently using a public here, and usually we derived inherit publicly. So this is a public, and we are deriving it from the person. Okay, and here from here you can see that your new class will start. So what we can do here in the public, because as we discussed here that a person has some data members. You can see over here the person has data members. It will be inherited by a teacher, and along with that we need some other data parameters also. We will need some other data, some other informations too, to make it a unique individual. So in the teachers too, I need the teacher employee ID and its specialty. So what I will do, we will need another string employee ID. So this is a new data variable which we have added here. And similarly we will also need its specialty, that to which domain in which domain he is expert. So this is the thing, that we have derived the teacher from the person class. So all the data members of the person will now be a part of that. So instead of writing that function show here, I should write over here to understand its working. Now in that show function, I will show all the data the teacher has. And currently the teachers had number of data. There are total 5 different parameters. The 3 are inherited from the person, and the 2 are from its own, from the derived classes. So I'm going to display all its data. So see out, and the first thing I will display the name of the teacher, and the name variable is name, and I will use the handle to go to the new line. So you can say name is not written in the teacher, not a part of the name, but currently we consider that we have derived the teacher from the person. Now the name is also part of that. And similarly I will use another thing which is address, and for the address we are using the keyword add and L for the new line. Okay, we have also inherited the third data member, which is cout, and that is a phone number. and phone number variable name is phone number and l. Okay, so we use the show function to show all the data members which we have inherited from the person. Now this the teacher also has some data members which are not inherited from the person, but it directly belong to the teachers. I'm also going to display its member. For example, the first name is employee ID, and the data members which we are using for that is employee ID, and similarly and to go to the new line. And the second its own variable is specialization at domain, and for that we have used the variable spec, and similarly and to go to the new line. So you can see that in the teacher class, though we have only two data members, but in the show function we are also displaying the data members which belong to the person. Why? Because we have inherited it over here, and we believe that all the data member of the person are now part of the teacher. So now go towards the main now, because the compiler only run the main function, and from the main we can send or we can call any other functions. So I'm going to create one teacher object over here, for example teacher, then object is teacher1, and against t1 I will set all the data from its parent class, from its, you can say all its own data members. I will set all the data. So t1, so with the t1, against t1 I can also set a name, because name is also part of that now, though it's belong to person class, but now we have inherited that, so name should be a part of that. Along with name we also can set its address to, because this address also belong to that now, and similarly the phone number also belong to a teacher now, because we have derived the teacher from the person. So we set all the data members which are not directly a part of the teacher, but they are part of the person, and the teacher has derived it from the person. Similarly, we will also set its own data. For example, the employee ID, everything is in a string, so I will provide some ID to it. For example, emp001, this is the employee ID, and similarly we will set the specialty to, for example its specialty is a cloud, and so you can say that I set all the data members for the teacher, which is actually deriving the data members from the person. So finally I will call the show function and will check that how it works. So t1 dot show, so according to rule regulations it will set all the data, either it is of its person, either it's its parent class, either these are its own data, yeah, these are its own data members, so all data will be set. And the show function is, because we have called the show function, so all the data will also be displayed. So let's have a look on that and check that either it is working or not. Yes, it's working. Now you can see that all the data for the person class, which is derived into the teacher class, it successfully inherited all the data members, it successfully set all the data members, and you can see that it successfully displayed all the data members. So it is exactly helping us that instead of defining all the data members for the teachers too, which are needed for the person, which actually will duplicate the data, instead of copying it over here, instead of inheriting it over here, it will duplicate the data. And in the object oriented programming, we avoid the duplication of data. We go towards the data reusability. So here you can say that we uses the inheritance, and we reuse all the data members from the person into the teacher, and it is perfectly working, as you observe in the program. So we should look at that once again. We should take the recap that why do we need inheritance and what is inheritance. Look at that program. Every time we discuss that classes and that program for the university. And for example, you agreed for the university program that you will include my teacher as object, student as object, admin as object, because all of them are having their own part in that program. And once you decided, then you write the required data members. You write some data members for the teacher, some data members for the student, and some of the data members for the admin too. But here you can see that the problem arises that some of the data members are repeatedly used for teacher, student, and admin. But in the object-oriented definition, we clearly know that we are going toward modularity, and we will avoid repetition. Instead, we will go toward the reusability. But here is the problem: we haven't reused that. We went towards the repeated data. So what we can do for that? For that, we can go towards the inheritance. We can create one, as you can see over here. We can create a person class, and at the person level, we can define all the data members which are common to everyone. And after that, we started deriving derived classes from the parent class, and the parent class will automatically get all the data members from the parent class. And we will also add some data members which specifically belong to the teachers. Similarly, the student will also get all the data members from person 2, and we will also add some of data members from the student. And here you can see that some of the data will also be, some of the data from the parent is coming here, and we are also including the department also. So this is the way that we can increase the code reusability, and we can avoid the code that the code should be repeatedly used. So this was about inheritance, and in the next lecture we will extend that. We will check the behavior of constructor and destructor, that how they behave in the inheritance environment. We will also look at the access specifier again, because we initially we covered the protected, we covered the private, but we haven't yet discussed the protected one. We already discussed the private and public, but we haven't yet clearly discussed the protected. So we will next check how the protected behave. We will also check the constructor and destructor. We will further also check the different type of inheritance. So thank you so much.